Hello everyone. In this session, we will fine-tune a few queries with index seek and scan operators. Let's get started. The first example I want to discuss is key lookup operations. Let's run these queries by creating clustered index on business entity ID first and non-clustered index on first name. Then I run this select query. Here you can see key lookup operation. What's happening in the background is, firstly, non-clustered index is being used to get rows where first name is Abe. Sorry about typos here, it should be ABE, not ABBE. But leaf node of non-clustered index is not covering columns other than first name, right? We don't have other columns, only first name here. But we need all the columns according to our query. Therefore, to bring other respective columns, SQL Server sends request to clustered index. For this request, it uses clustered index key here, 120. Therefore, we call this process as key lookup. By using this key, then we search in clustered index and bring other columns also. We can also confirm the same in execution plan. If you look at the properties of index seek, you can see non-clustered index name where we are doing seek operation. This seek is based on this predicate. After finding target row by using inner join, we are doing key lookup in clustered index. I'll explain how inner join works in the next sessions. Key lookup operation is not necessarily a bad thing, but the operation required to first read from the non-clustered index, followed by extra read to retrieve the data from clustered index, can lead to performance problems. Therefore, in order to stop this long key lookup operation, SQL Server offers include option while creating non-clustered index. By including columns in non-clustered index, you can add columns in leaf node. As a result, SQL Server does not need to go to clustered index to bring columns and do key lookup operations. Okay, key lookup operation is omitted here. This can make your query faster. Let me show you. I have total 3 columns in person2 table. So, since business entity and first name is already in the leaf nodes in non-clustered index, we should include only last name in non-clustered index. I dropped non-clustered index first and recreate it by including last name column. As a result, if you run select query again, you can see key lookup is omitted. This is expected to make your select queries faster. However, using include option and increasing the number of columns in non-clustered index comes with cost. First, additional disk space to store columns in non-clustered index, right? Then additional overhead of maintaining index. More time required to rebuild and reorganize indexes. And insert, delete, update operations might become slow as further changes are needed in non-clustered index. Therefore, you should carefully implement include option and design your indexes. The next often given question is seek always better than scan? Which operation is faster? I can say it depends on your data structure and queries. We can never say seek is better than scan or index seek is better than table scan. Why? Sometimes quickly scanning the whole table might be faster than going through the whole index architecture. Or, on the other hand, sometimes seeking one particular value can be faster than scanning the whole table. Let me show you a few examples. First, I create sample table. Then we create clustered index and run this select query. As you can see, we are doing index scan and we are doing this number of logical reads. In other words, we are reading all the rows in the leaf node of clustered index one by one, going through the whole table. Now, as we are using store ID in where close, let's create non-clustered index on this column so that index scan changes to index seek. Here, you can see operation changed to index seek and number of logical reads is significantly decreasing because we are not going through the whole table right now. We are just finding a key and bringing specific row from clustered index. In this case, we are achieving much better performance with index seek as we are doing less reads. Of course, as discussed before, we can create including non-clustered index here and omit key lookup, which can further improve performance. I will leave you to try this by yourself. Now, let's see example where table scan is better than seek. First, I create sample table. Here, we can see table scan operation and this number of logical reads. Now, let's create clustered index on where clause predicate and try to change this to seek operation. You can see here we are doing seek, but interestingly, we are doing more I/O operation. Why? Because we should also bring the pages of index architecture, right? Leaf nodes and middle nodes, right? So it might make a little bit difference and increase I/O operation. In this case, we have little data, but when we have a lot of data, this number can become very much significant. This clearly shows we cannot say specific operation is better than the other. Of course, there is a general accepted fact that we can often, I can say very often, achieve better performance with seek operation. Because seeking specific value is much more efficient rather than scanning the whole table, right? This is true. But you should also know that sometimes scanning operation is better than seek. SQL Server often predicts a correct way to use scan or seek based on statistics, right? But you should also take this into account by yourself while tuning your queries and by creating index and changing to seek operation, because incorrectly created indexes might make the index optimizer choose different operators and create inefficient execution plans. I hope that you now understand how important it is to create correct indexes and how index scan and index seek can be tuned. Happy learning!